Alright, looking at problem 3, we need to identify its parent function. So, parent function is just ignoring any addition, any subtraction, any multiplication that we see. Well, the log base does not involve any of those three functions. And then I ignore any subtraction and any addition, no matter where it may be. So the parent function is just y is equal to log base 3 of x. And that's it. What is the inverse of the parent function? So we just need to change the x and the y. So I would just have three to the y equals x. Because again, the whole point of logs and exponentials is it wants to get either x out of our exponent, or if we're trying to solve for this, we're trying to get that by itself. It's basically what logs and exponentials do. What is the asymptote of the inverse of the parent function? That would just be y equals 0. That's the asymptote of every exponential parent function, no matter what you got. What is the asymptote of the parent function? Which would just be a vertical asymptote of the original, which would just be an x equals 0. Alright, and that's it. That's all. Making a t-chart of the inverse parent function, which again was that y equals 3 to the x. So I would have probably -1, 0, 1, and 2. Plugging in -1, I'd get 1/3. Plugging in 0, I'd get 1. Plugging in 1, I'd get 3. And plugging in 2, I would get 9. Find our parent function by flipping those inverses around. So my x and my y would just be flipped, so I'd have 1/3, -1. I would have 1, 0, I would have 3, 1, and I'd have 9, 2. Alright. What are our transformations? Well, if we remember, we had log base 3 of x minus 4 plus 2. Alright, so from the parent function that we originally had, the only things that I really ignored was that -4 and that +2. So that -4 on the inside of our function is going to shift everything right 4. And then that +2 on the end is going to shift everything up 2. Alright. So, what does this say about our asymptote? Well, our asymptote should now be at x equals 4. Alright, because again, my log functions are going to have an x equals line, and that should just be affected by my shifts either left or right. So going right 4 should shift my asymptote to being at 4. Again, and that's just because normally your asymptote for log functions is at x equals 0, and we shifted it right 4. So my asymptote is going to get shifted right 4. And now we just take a look at the t-chart for the parent function, and we shift all of those points right 4, and we shift them up 2. So 1/3 getting shifted right 4 would just put me at 4 1/3, and then up 2 should put me at 1, which will be about right here. Taking that point of 1 0, shifting it right 4 should put me at 5. Up 2 should put me at 2. Shifting 3 1 right 4 should put me at 7. And then up 2 should put me at 3. And then finally taking that 9 2, shifting it right 4 should put me at 13, and then up 2 should put me at 4. So 13, 4 should be about right here. And now all I gotta do is connect the dots, and I should be done. And again, that is probably the easiest way to do those, because otherwise plugging in numbers in for logarithms is not the funnest time in the world. And the only other way that I know to do these is literally sitting there and memorizing tables upon tables upon tables of numbers, which some people don't even know their multiplication tables. So I don't want you guys memorizing long tables, because they're really not that major. Okay, just find your exponential points and switch them. It's the easiest way. I promise you that. And if you can find another way, because for some reason your parent knows it, let me know. But this is the easiest way I have found in my years.